All right, this is the second video for January 5th, January 8th. We already looked at solving these two. Solving this one by doing the greatest common factor. Solving this one by solving a quadratic. And then once we have 0 on one side, which is a key piece, then we can set each of our factors equal to 0 and solve from there. So let's go ahead and look at these two. We have 0 on one side. So the idea is, can we factor these, set them both equal to 0, and solve? Well, here, if we look, it's not a quadratic like this one because we don't have the term with just x in it. We do have the x squared and the constant, but we don't have this x term. It's not like this one either because we don't have a greatest common factor. No numbers go into 9 and other than 1 that go into 9 and 16. And this one has an x squared, but the 16 doesn't. It doesn't have any x at all. So the idea is can we use a different type of factoring method here? And if we can recognize that, what we can do is rewrite this as something squared minus something squared. Oh, I was put it to the fourth. What am I doing? Set squared, root 4. So if we wanted this something squared, we'd have to have something in here that when we squared it, we would get back to 9x squared. So that quantity would be 3x. Since 3 squared is 9, x squared is x squared, and this squared would be 4. 4 squared is 16. And so because this is what we call difference of two squares, and in the previous video I showed why it factors in this way. So I'm not going to go through the showing why it factors this way, but it would be 3x, whatever this quantity being squared is, plus whatever this quantity being squared is, and then 3x minus 4. It could also be 3x minus 4 times 3x plus 4. Doesn't really matter the order in this case. And then we have a quantity times another quantity equals 0. So we can say, hey, this guy could be 0, or this guy could be 0. Since if this is 0, we would have 0 times whatever that is. 0 times whatever is 0. Or if this is 0, we would have 0 times something, which is 0. And now we can solve these two equations. We can subtract 4, divide by 3, and get x equals negative 4 over 3. Similar thing here, add 4, divide by 3, and get positive 4 over 3. All right. So it's a very similar concept as to the problems up here, just a different type of factoring method or technique to get to that solution. Last one we're going to do on the video here, we have something squared, we have the x term, and then a quantity or a constant on just a constant. So this does follow quadratic. However, we don't have, we have a number or a coefficient other than x squared in front of x squared other than 1. So you could either do the trial and error method, but I'm seeing a lot of students do what we call the AC method, which is also okay. What the AC method says is, hey, I take the A value and I multiply by C. So you get plus 30 equals 0. Now we don't have that value there, and we're looking for two numbers or a product that give us 30. And those same two numbers should add or sum to give us negative 17. So two numbers that multiply to give us 30, that add to give us negative 17. Those two numbers would be negative 15 and negative 2. Negative 15 times negative 2 would give us 30. Negative 15 plus negative 2 would give us negative 17. So our factor, it would factor in this way. However, because we multiply by 5 here, we do need to take care of that by dividing our values here by 5. And this would become 15 divided by 5 is 3. 2 divided by 5 doesn't simplify, so the 5 moves in front of x. The AC method, it's a trick. I don't like it personally, but it is something that a lot of students use because they see that it can be used in any quadratic, and as long as you remember some little tricks along the way. And then we can solve both of these. I'll let you do that, but if you solve correctly, you would get x equals 3 and x equals 2 over 5 from this one. If you have questions, pause, rewind. You could also ask those in class. I would be happy to answer those questions as well. And these last two, just really quick comments here. Different because we don't have 0 on one side. Here you have an equation, we don't have 0 on one side. Similar thing here, different equation, not 0 on one side. And that's an important thing. If we're going to solve by factoring, 0 would have to be on one side so that we can set both of the pieces or both factors equal to 0. Here, if we want to get 0 on one side, we could do this. Here, I'm actually going to move these over there because I know if I add 5x cubed, then I'll get a positive coefficient in front of my cubed term. Those will go away. Now we have 0 on one side. Here you have a quadratic that factors here. I'll let you think about what you can do there. If you want me to check either of these, that's fine. Bring them in. I'll definitely check them. We can talk about that. I'm going to go ahead and flip to the back side. I've already solved all of the ones on the back side. So if you want to pause this, try the ones on the back on your own. That might be a good idea. But I went ahead and solved them just in case you wanted to check your work. Make sure you're moving in the right direction. You had 4 equations. Here are the first 2. So if you need to pause to make sure you see those solutions, work it out, that's fine. Similar thing here, 3 and 4. There would be those solutions for numbers 3 and 4. Again, if you have questions, please let me know. We're going to continue working with factoring, continue that later. We're going to move away from factoring polynomials for a few days and then go back to factoring in a different context. So these concepts will keep coming up in the future. But if you have questions in the meantime, please feel free to ask, reach out, use the Remind app, email, website. All of those things would be great.